Hi everyone. I'm going to do this talk in English for the guys in Ljubljana. My name is Maor Frankel, and I'm a developer on the Amplify dashboard team. And I'm going to talk to you today about micro frontends. So first of all, here's Google's trend chart. What we can see is kind of the development, the progress of. We can see that during the last 2 years, the term micro frontends has become really popular around the web. A lot of people are talking about it, but I'll give you a little warning. A lot of that talk is buzz, because there's a lot of talk about the actual concept of what is micro frontends, and there's very little talk about how to actually implement that. So there's a lot of theory and not a lot of practice. And that's what we're going to try and do today. So what's on schedule today? Well, first of all, why do we need it? What's the problem today, and what are we trying to solve? What is it? What are the kind of available technologies that we have out there to use? And what are the different approaches that we can take in order to solve this problem that we have? We're going to show a little demo about how we did it in our team and our solution. That's it. So to understand why we need micro frontends, let's talk a little about what the problem is. And to understand the problem, we have to kind of go back in time to the early days, of web development. Some of us are old enough to remember that in the early days of front-end development, the whole application was just one big giant app. It had all the front end, the back end, all the CSS, everything was kind of bunched up together. Front-end developers, back-end developers, everybody did everything. Everything had to go through one huge build, deploy to production. And I remember in my old company, it took about 3 hours to make a build. Usually that failed about 2-3 times. So that usually failed for about 2-3 times, and that kind of took the whole day just to deploy a single version into production. And that was okay for a while, but over time that didn't really last. So at some point somebody had the good idea of separating the back end and the front end, and that way, first of all, you had teams that are developers that are experts at their technology and not just with everything, and also made deployments easier, and it made the code base much easier to handle. And again, so somebody had the good idea of creating microservices. They decided to break the backend apart to different services based on business domain of each one of the groups that handle it. What happened is that you had small services that were managed by teams that were experts at their business domain. For instance, you had a team that managed business operations, teams that managed payments and things like that, and they were experts at what they did. They had small applications which they could easily deploy to production, build, test separately, and that was great. But the front end kind of stayed the same, right? Nothing changed. And that was okay for a while because front end applications were pretty small. There wasn't much that they had to handle. But like everything else, over time, applications got bigger. The front end kept getting bigger and bigger. And not only did it get bigger, it started to have a lot more responsibilities. I'm from the dashboard team, and what we do is basically we allow companies, the buyers for the company to create ads, create campaigns, manage their campaign settings, get reports. And at the beginning, we only had kind of reports. We had a little bit of campaign settings, and that was okay. But over time, we started having, started to have to manage conversions, and we started to have manage audiences and segments, and payments and billings and video campaigns, and we're not experts on any of that. I mean, I know a little bit about reports and campaign settings, but all the rest. So I can be pretty good at everything. I can learn a little bit of this and a little bit of that, but I'm not going to be an expert at everything, right? I mean, at some point, it's better to know a few things excellent and than a lot of things just so-so. So the situation is today that you have this kind of super team, right? You have one team that has to know everything about everything. We have to work with all the different kind of back-end services, different teams. We have to know everything, and that's not going to work for a very long time. So now that we decided that there's a problem and that we have to start moving forward, what can we do? Well, first of all, this is what we want, right? We want to work in verticals. We want to have teams that are experts at what they do at their business domain. If we have, you hear me okay, the feedback? Yeah, we want to have teams that are expert at business business aspects of the team. You want to have teams that are experts at payments, at conversions, and all these things. And they should be able to manage their front end, their back end, and that should be one pillar that really knows everything about their business aspect. And as far as the actual application, you want to have one page where you have different kind of applications. Sorry about that. Then, better? Can you hear me? All right, so I'll try and. Sorry about that. Can you hear me now? Yeah. All right, sorry about that. So this is what we want, right? We want a web page that has different applications running on it. Each one of these applications will be managed by the specific team that manages that part of the application. You'll have a team that manages the payments. You'll have a team that manages the products. And all those will sit on a single page. The user will have a seamless experience. And each one of these applications will be managed by a different team and loaded into the page and work together at runtime. So in order to achieve micro front ends, let's first of all talk about what that actually means and what do we actually implement. So we have a few key things that we said that are the criteria for us to actually achieve this goal. These are things that we said that we need to implement and priorities that we want to set in order to achieve some kind of solution. So the first one is encapsulate CSS and JavaScript, right? Because if you're going to have a few applications running on a page, you don't want them to collide with each other, right? You don't want JavaScript, two applications using the same namespaces and breaking each other. CSS is obviously going to be a problem. So there has to be some kind of form of encapsulation. Performance, I mean, if you have 10 applications on the page and it works great, but the user's getting a shitty experience and the page doesn't load, then we haven't done anything really. A very important key is team ownership. We want to be able to, each one of these teams to be able to manage their application on their own. We want them to have to be able to build their application. We want them to deploy that application to production without having to interfere anybody, without having to wake anybody up on a weekend. We want them to be able to test their application separately. So that's very important to have team ownership. Any solution that we have, we want to have future-proof. We don't want to invest in something that is not going to be relevant in 6 months. Things are moving fast, especially everything to do with front end. And we don't want to make an investment that is not going to be worthwhile in a few months. Sharing basics. This kind of ties into performance, but we don't want to be able to either duplicate code and duplicate modules between applications. We want all the different applications to be able to share certain things. Again, that also ties into performance and seamless UI and UX. We want it to have a single feel, and that means sharing certain aspects of our applications. We want the application to be modular. We don't want to be able to work only in one part of the application or for one different team. We want it to be able to be reusable. If in our company, if Amplify needs some widget and Engage needs some widget, we're not going to write it twice. We want to be able to use the same widget all over these different applications that we have. These applications need to have some form of communication between them, things like deep routing, sharing state, at least at some level. So that's something that needs to be possible. And it has to have some kind of seamless UI and UX, right? At the end of the day, if the user feels like he's going through 4 or 5 different applications when he's working, then we're going back to the day of multi-page applications. We want him to feel like there's one application, and these applications need to be able to work and look like they're part of one big application. And also, since this whole concept of micro front end is kind of in flux, This needs to be something that's easy to implement. We don't want to invest very heavily on something that we don't know what the future is going to hold for it. We don't want to invest something that we're going to have to throw away. So these are kind of the points that we put out before we started our development, and these are the things that we wanted to, to have implemented in our solution. So, question is there anything out there that is off the shelf? Is there anything that we can, pick up today, plug and play, and just start using? Especially in front end, that's quite popular, but in this situation, not so much. Like I said, micro front end is mostly a concept. I mean, there's a lot of people kind of trying to make different attempts about solving it, but there's nothing out there that is like a de facto solution. There's actually very few things that actually really tackle the problem. But that's not, there are a few cases, there are a few situations where there are companies who are trying to do solutions. Most of them are partial solutions. They don't give you the full solution from end to end, like deployment and everything. But we'll show you a couple of them. The first one is SSPA, which stands for single page application. Not the best name. Can you see it? So this is the page. It's by a company called Taxonomy, which I've never heard of. We can see a little demo of what they've done. So they got this framework inspector, and you can see you kind of have a header that's being built in React, and you can also have React and Angular JS on the page, and React and Angular is slow, and Vue, and all these different frameworks, and they can all work on the same page and live quite harmoniously together. And actually, this is probably the most promising solution out there, and they've been working on it. It looks pretty good. Most of what it does is manage the whole bootstrapping and managing the different boilerplate between the applications. So it's definitely promising, but it's still not a complete solution. Sorry. Where did we go? So the reason that we didn't go with this solution is because I don't know this company. I've never heard of it. I don't know. Has anybody else heard of it over here? And I don't want to invest our solution in something that, a company that could go bust in a year, and then we're going to be stuck with something that nobody's going to support. But it's definitely something to keep an eye on in the future. Another interesting solution is Angular Elements. It's an attempt by Angular to be able to write components in Angular and compile them into web components, and that way they can work seamlessly with other frameworks, with other applications. They can be moved around quite easily. It's also very experimental. They're still working on it, but it's definitely something that you want to look out to in the future. So, now that we understand that we have a problem, how are we going to, if we don't have anything off the shelf that we can use, what can we use? What can we do in order to get to where we want to? Well, first of all, one of the things that we have to work out before we talk about this solution is how do we actually get the different applications on the page together. So we're going to talk a little bit about the different approaches that you have for doing that. The first one is good old iframes. We all know iframes. We all know what they can do. They've been around for a while, and they're very good at what they do. They got a lot of pluses, and they got a lot of downsides too. They provide perfect encapsulation. Anything that runs in an iframe is completely encapsulated from the other applications or anything else that's on the page. They can provide great team ownership. Anybody that has an application can create it, deploy it, and it can be served on a page, and they can deploy it separately, and it can be used anywhere. So it's also modular, and it's very easy to implement. I mean, you can take your application right now, shove it in an iframe somewhere, and anybody can use it. But it's not very performative. 3, 4 iframes on the page might be okay, but each iframe loads all the resources from scratch. It boots everything up from scratch. And if you're thinking also about mobile, and if you want to scale up, that's not going to hold water if you're talking about 9, 10, 11 iframes on the same page. It's definitely not future-proof. I mean, I don't think there's any new APIs or anything coming out for iframes, so this is not something that you can count on for the future. You can't share things between applications. I mean, I guess you can in some way, but it's very, very difficult. Communicating between iframes is a problem, especially things like deep routing and stuff like that. That's going to be a big problem. And seamless UX, UI, I mean, iframes rarely look like they're part of the whole applications, right? Usually you can tell when there's an iframe on the page. And if not, you have to work very hard for that not to look like that. So another approach, build time composition. That can be done usually with NPM or maybe some kind of MonoRepo, where each team has an old folder and everything gets built together. So the idea is you have one application that consumes all the other applications either from different folders or from an NPM package. All those things are built together in one big build cycle. I mean, people here maybe remember the super trunker in Outbrain. How much fun it was to break the build and then go out to lunch. But that's a way where teams can have some kind of separation of code. It's pretty good on performance because it's one big application. You can share kind of basics together pretty easily because it's at the end of the day it sits on the same code base or same repo NPM packages which you can shift around. Obviously, it's modular because you can use them all over the application. Communication is great. It'll look great because they share the same CSS and UI. Very easy to implement, but the key problem for us was team ownership. I mean, you can have your own NPM package and you can kind of publish versions, but there's no way for you to deploy it to production. At the end of the day, you're going to have one application that contains everything, which is going to have to be deployed to production. And if I have something that I need to deploy to production on the weekend, I don't want to have to rely on some other teams breaking changes for them to fix it just so I can get my fix to production. The last approach I'll talk about is runtime composition. So what runtime composition talks about is having different applications deployed to production, some kind of packaged JavaScript file that sits somewhere. And an application on runtime will pull all these different small applications into the browser and bootstrap them all into the page, and they'll all work together seamlessly. So this has a lot of advantages, most of all the fact that you can deploy any one of these separately to production. The teams have complete team ownership. They're free to deploy, build, and test their applications independently. It's good on performance because you're not having to rely on any iframes or anything like that to do it. It's definitely future-proof because you're not relying on any kind of technology that might be obsolete. You can share things if you know how to do it right. It's definitely modular because you can use these. Anybody can pull one of these micro applications into their page. You can have some form of communication, and well, having seamless UI and user experience is really dependent on your implementation. But it's not very easy to implement. It's very hard to have something deployed to production and be pulled by other applications during runtime. So how do we do all of this without completely rewriting our application and throwing everything away? So we decided to kind of use what we have already with a little bit modifications. So now we get to our solution. In our solution, we decided to go with runtime composition because we thought really that's the way to go. We decided for now to forego multi-frameworks. We decided that, I mean, one of the ideas was to have a lot of kind of different frameworks on the page, React, Angular, and all that. But, you can argue about that, but I don't think that having React and Angular and Vue on the same page is very smart because each one of these has a very big footprint and they weigh a lot. They have, it can have an impact on performance. And honestly, at least my opinion is all these frameworks don't do very much anything different. I mean, at the end of the day, they all make components. So I don't see why I would want to have a few of these frameworks and pay that big penalty just to have the same thing. But that's something that we can look at for the future. For now, we decided to put that on hold. We don't want to rely on any third-party tools, nothing that's really going to leave a big footprint. We want to kind of have something that we can implement easily and then maybe change in the future. We're going to use Webpack. Everybody here know what Webpack does? So Webpack is a bundler that bundles your application, and one of the good things it does is it creates a namespace for each one of your bundles. So that way you get kind of a JavaScript encapsulation, And Webpack can also put CSS and HTML and everything inside one of these bundles. So you can get one big JavaScript file that basically represents an entire application. And we also decided to use a little bit of help from our friend Angular. Since we are already using Angular on our pages, why not use its capabilities? And it's actually quite suited for what we want to achieve. So anybody here knows or don't know what Angular models are? So Angular models is a way in Angular to define a certain part of your application. They're usually feature-based. They can also represent an entire application. It's basically a manifest file where you provide all the dependencies for a single module. It provides encapsulation because it defines all the dependencies that a single module needs. It can expose components out, which is something that we want. We want to be able to share things between applications, and you can state, you see here, you can state what components you want to share out and expose out to other modules. They can run either as independent applications, or they can run in a container app and be shared throughout the application, which is one of the other things that we wanted to achieve. And it even has its own routing tree. So it can be completely independent. It can have its own deep routing, and it doesn't have to interfere with any kind of, you don't have to define routing on some parent application just for that to work. Angular also lets us lazy load these applications. It has an API built in where you can state the module and the path, and you can lazy load that module during runtime. So you don't have to load 10, 15 applications while you're working. You can load them only when the user needs them. You can also do that programmatically, so you don't have to rely on routing. You can just have a specific API where, if you can see, you can import a module and then actually through the API bootstrap it into the application and use it throughout. So these are things that are very useful for what we want to achieve at the end. But there's a problem with this. The problem is that this solution was designed for working during build time. What that means is that when Webpack builds your application, all the dependencies between these different models that you want to separate, they all rely on certain namespacing that Webpack gives you. So if you look at the way Webpack works, if you see here, we have some kind of an import statement. We're importing component from Angular. But what it maps to during runtime is this. Webpack separates the import into a require call, internal require call, and it maps it by an index. And that index is unique for each build. What that basically means is that if I take two chunks that were built by Webpack, that were built in different times by different machines, and I put them together, they're not going to be able to communicate with each other because that index is going to be different between each one of these applications. So that's a problem because we want teams to deploy and build their applications at different times. So how did we solve it? Well, we decided to build our own loader. I don't know how many of you have written a loader for Webpack, but it's not much fun, but it's definitely interesting, and it can give you a lot of tools, by the way, for achieving things that are not custom, that are not built in, that are custom for you. So what does share loader do? Share loader is just something that you define in the Webpack config. What you do is you define a list of modules that you want to share between applications. This would be the container app, which actually has Angular or any other module in it, and it wants to expose it out. So basically this says, I want to expose Angular and all the different sub-modules of Angular and UI router. I want to expose them out. I don't want to have every one of my micro applications reuse these modules. I want them to share it with the one that I have. And I also have to define some kind of namespace where the other applications know where to look for that, for those shared modules. And this is the output. The output states, I mean, you don't have to really read it, but this is what Webpack produces. And you can see here that we expose the container app inside the Webpack namespace. And this would be the configuration for the child app. You would also have the same list of modules. You don't have to, by the way. You can share what modules you want to share with the container app. You can have certain modules that you don't want to share because you want your own version built inside your chunk. But you do have to declare the same namespace so they know where to look for each other. And you have to define it as your package as a library. This is just a way to tell Webpack that you want to expose some of your things externally. And again, this is the output that Webpack produces. If you want to go look after and read it and make sense of it, feel free. But again, it just uses the same namespace to expose Angular, the common, and consume it from the container application. All right. So any questions, by the way, so far? You can ask in Hebrew, too, if you're not comfortable. Great. So, so how is this actually going to work? You know, what's going to be the kind of workflow? So you're going to have a few different teams working separately. Each one of them is going to have a code base. They're going to work on the applications locally. They don't have to have dependency on any of the other applications. They're going to commit their changes to their code base. That's going to go through a Webpack build. That Webpack build is going to use share loader and extract all the dependencies that we defined outside, except for the container app, which is going to have a reference to those dependencies externally. Each one of these is going to produce a bundle, which is basically a JavaScript file that contains everything that application needs to run. And that's going to be deployed to a service somewhere, wherever your services are maintained. And there's going to be a service in there that's sitting, holding that package, waiting for somebody to require it. And how is that going to work on runtime? Well, some user is going to log into his favorite browser. He's going to ask for your application. That application is going to get pulled from your container application. And he's going to see just the basic application that he's required. When he wants any one of those micro applications, his browser is just going to make a call to any one of these services, either the payments team or reports team. It's going to call their services, and their services are going to return a bundle. And that bundle is basically the application, JavaScript, and everything that it needs in it. That's going to be loaded into the application. It's going to be bootstrapped by Angular, or you're going to use some other framework in the future by that. And all the dependencies are going to be used one time, at least the ones that you define that are going to be shared between them. And they're all going to share that common namespace and all the dependencies that they need together. And this is actually how it looks. This is the request URL that the browser is going to take out. So if you look at this, the browser is going to call video campaigns creation. It's going to call their API, and they're going to expose an API. We call it external, but you can call it whatever you want. And that's going to return this. And this is the actual response where it states the application name. So we know what applications we're actually loading. The file that we want to, that's the actual JavaScript chunk that we're going to reuse. And you can see we have cache busting here. We can manage versions if you want to maybe use a different version. So the applications that I'm requesting the chunk for, that can give me back whatever it wants. So it can manage its own state. If it has like a breaking change, it doesn't want to expose it out, it can just set it for a specific version, and that way it doesn't have to break anything. You can even use that for kind of feature toggling. And also it defines the module name that it wants to expose. And this is important because what this means is that each one of these services doesn't have to be, doesn't have to have only one application that it exposes. It can expose many modules. So the video team, for instance, can have a module that is for our creating campaigns. They have a model for editing campaigns, and it can share all those different models with one service. And basically, it's free to do as many of these as it wants. So as far as communication is concerned between the different applications, you know, there's a lot of ways of doing this. We decided to go for an event bus solution. The reason for that is that using events is the most decoupled way to have different parts of your application talk to each other. And we wanted to have it decoupled as much as possible because, like I said, we don't know what the future holds. Things might change in in some months. Maybe some kind of company will come out with a brilliant solution that's going to solve all of this. And we want to be able to migrate our solution out. And by using events, that's something that is global. You can always use events to communicate no matter where we are. You can do it through the DOM API or just an event bus instance. So in our solution, what happens is that each one of these applications, when you bootstrap, it gets an instance of an event bus service. And it's a single instance. The reason for that is we don't trust our applications to clear the memory behind them. We want to make sure that whoever uses that application doesn't leave any memory leaks behind. And if we provide them with that instance, we can destroy that instance when the application is being destructed. And that way we can ensure that we don't have any leaks left behind. That's it for the solution. If anybody has any questions, or you want to just see the demo? All right. So can you see okay, or is it all fuzzy? All right. So this is the video campaigns application. This is one of the applications that, one of the teams that are writing an application for us, the video create campaign application. Yeah, I haven't gotten to the good part yet. So if we look at their Webpack, they have a Webpack config for development, and they also have a Webpack config for production and for their production environment, and they also have a Webpack config for external. And if you look here, we have our share loader defined here, and you can see that the video video application is requesting to use Angular, UI router, and NGX popper, which is our tooltip library, because we don't have to have that multiple times on the application. So there. And yeah, this is the video campaigns creation. That's the guest application. And in our hosting application, which is the Amplify dashboard, we have the same thing, just with a little different syntax. And here we say the same thing. We want to expose out Angular, we want to expose UI router, and we want to expose NGX popper to any other applications that want to use that. That's basically the whole entire configuration that you need to make this to work. So let's see it in action. First of all, we have the local web server for the video teams running. It's just a backend service node. It has its own API, it has its own services. It can be used for them for any use they need. And we can just run it locally. And we also have, we can run the application. Yeah, there we go. We can run the application in their browser. So this is the actual video creation tool. And you can see it runs completely independent from the parent applications. And it even works locally against their backend service. So I'm not sure everything works, but you can even put a URL here. You can add a title. So create the content. You can even play the video. So this works. What this means is they can work independently. They don't need to be part. They don't need another application to run or work in order to do their job. Because if the main application is down, we don't want them we don't want that to interfere with their work. And that's very important for teams to be able to work independently. And they also have another build that runs. And this build creates the JavaScript file that the main application is going to consume. So if we look here, we can see in the dist folder, we have a folder that's called external. And we have the Webpack chunk that this is going to be consumed by the parent application. So this is built by the actual application. It has two versions. It has the versions that run or in a machine somewhere where it can be used independently. And it also uses a part of itself where you can say, anybody wants to use that part, you can just give me a call and I'll hand it out to you. And now we can see how this actually works on our application. So if anybody hasn't seen it yet, this is the Amplify dashboard. And the flow for the video campaigns is you just select add campaign, select the video campaign. This part of the application is just a regular create campaign for Amplify. We don't have to have two of those instances because it's basically the same. You can create some campaign. Hold on, I'll open the browser. Actually, we preload this. So I'm going to do a refresh. And if we look at the monitor, in a second, we can see that we've already made the external call outside, like we saw before, and we've done it to the local host, the one that we're running on my computer right now. And its response is what we saw before, the video app, the actual file that needs to be exposed, and the name of the module. And if we look further down, we can see that we've actually pulled in that module into our application, and we've bootstrapped it to our applications. So once we go through the name of the application, we can see in the content, and we see the exact same application that we saw before running inside Amplify dashboard. And the behavior is exactly the same. The only difference is, if you can see here, we have communication between the two applications. So when I add content, you can see up there that the number of ads that has been increased. And this part, the top part, is part of the main application. So we're sharing information between these two applications. And not only that, if you look at this, I didn't show it before. I said before that we share the tooltip library. So if you look at their applications, they didn't put any styling on for their tooltip library. They didn't need to. I mean, it looks broken over here, but when you come into our application, their tooltips look good. Why? Because we share the CSS and styling of our tooltip library to them. That way, they don't have to duplicate that styling multiple times. They can use ours, and if they decide to move to a different, work within a different application, they can inherit that styling from them. And that way, you can have a concise UI and an experience. That's it. If we add other titles, you can see that it's been updated too. That's it. That's the demo. Oh, close the slide. Well, hold on. Sorry about that. Questions? Yeah.
Can you give some more information about the past? What type of information decided to share between the companies? What type of events do you fire and direction?
So, well, basically, any event that you want to fire or you define between the two teams, you can have it. We've also declared a few basic events that are global, like lifecycle events. You know, the application is loaded, the application is closed, and things like that. So the application knows, you know, the basic lifecycle hooks of its existence on the actual page. But at the end of the day, it's something that you define. You can share any information, and also an event. If you fire an event that nobody listens, then that's okay. You know, so if it's you don't have to really be specific for each application that this is running in. So even if you fire events that are, you know, pointless, then there's not going to be any bad side effects.
Another question is, besides building the framework, you also hosted the team that wrote the video. You put them into Velocity and do the integration. So, at the point of view of someone who did that, what's your observation about hosting different teams within your team, regardless of the technology?
Yeah, so obviously there's some, well, one benefit obviously is you get to work with other teams and you get to know them better, which is also always a plus. But except the initial bootstrapping time where we had to kind of learn how to do this thing, because this was experimental, I think at the end of the day, they can, every time I look inside their application, I can see things change. I can see they work independently. I can see they do their work without having to bother me and our team. They deploy to production whenever they want. Obviously, you need some kind of integration testing to make sure that things don't break. But at the end of the day, they have the freedom to work as much as they want without interfering with our work. And our work, more importantly, it doesn't interfere with their work. So if we break our application, they can still work locally and they can still do their job without any interference. And I think it's starting to pay off now, and it's going to continue to pay off in the future.
Do you have some integration that checks the whole app?
Yeah.
The whole microphone?
Well, we're still working on that. But at the end of the day, you should have, tests for the separate team, which tests their application locally or on their machines to test all their APIs and their flows. And I think there should be a very thin layer of integration testing that just checks that the actual bootstrapping, loading, and all, basically that we share the events work together. I think that way, and that should be shared between the different teams, so I don't break their application and they don't break ours by some kind of mistake. But you need to have those tests for sure.
Another question. Think about making some shared micro frontend up just for the shared dependencies. So like we would have some kind of incremental field that you will be notified that maybe a common library was changed and you will need to trigger a new deployment just to test it out.
So I think for that would be a better use to use some kind of NPM package. For instance, if you want to have styling that is common, it would be good to have an NPM package which holds all the styles. Both applications can consume it, and that way when they build, they can see that dependencies have changed and they want to maybe look. Yeah, so I think that would be better to use a NPM package, because that's something that each one of these applications can consume. It's shared between them, and you do want to know that on build time that something has changed as far as the versioning. As far as sharing thing in runtime, like I showed you, we can expose any module. We can even expose a module that contains CSS, and everybody can use that. But again, that might have problems with changing that during runtime and not being able to know.
That was what I was asking. Take the whole common modules, take it out from the container app and move it to some common app.
You mean another app that has all those common things? Well, I would prefer to have it in. Sorry. Yeah, but that's an NPM package, so you could do that. You can have it either in an NPM package where everyone can say, or you can have it in another application that's micro front end, and everybody can consume that during runtime. I don't see much of a difference between any of these approaches. I'd probably still go with NPM because it provides kind of versioning management that's a bit better. But I think that depends on whatever implementation you prefer. Any more questions? So.
Someone from Ljubljana, maybe?
You can say it in Slovenian too. All right. So thank you very much for listening. If you have any other questions afterwards, you can talk to me or the video team, which are writing the application for us. They can give you some of their experience. And that's it. Thank you very much.